Welcome back, Deep Divers. Today we're going to try to wrap our heads around a pretty big roadblock in AI.
Oh, really?
Specifically, how to train those large language models, how to get them trained faster, more efficiently. And for this deep dive, we're going to be looking at a paper called Balancing Pipeline Parallelism with Vocabulary Parallelism.
Interesting.
It's got some pretty cool techniques in it.
Well, what's really interesting about this paper is it kind of shines a light on a challenge most people don't even think about. The whole vocabulary size, how big it is.
Right.
How much it affects how we train these things.
Yeah.
Especially with this thing called pipeline parallelism.
Pipeline parallelism.
Yeah. So picture this, like an assembly line, right?
Okay.
Where different people are working on different parts of, like a car, let's say.
Right.
All at the same time.
Yeah.
Gets the job done way faster.
Makes sense, yeah.
Well, pipeline parallelism does the same thing, but for training these big AI models.
So instead of training the model like piece by piece, we're training multiple parts all at once.
Exactly. It's like a well-coordinated team effort.
That makes sense, yeah.
But here's where the vocabulary size comes in and messes things up a bit.
Okay.
These models, they've got huge vocabularies, like hundreds of thousands of words.
Wow.
And the input and output layers, the parts that handle all these words,
Right.
they create like these uneven workloads
Oh, okay.
and memory demands across the pipeline.
I see. So it's like one part of the assembly line's working super slow while the rest are going full speed ahead.
Exactly. The sheer volume of words creates a bottleneck.
Gotcha. So it slows down the whole training process.
Exactly. And researchers, they've been trying to fix this for a while.
Okay.
Some training systems, they try to redistribute the transformer layers.
Transformer layers, just a quick refresher. What are those again?
Sure. Think of them like the building blocks of these language models.
Okay.
They process and understand how words connect in a sentence. So redistributing them is meant to, even out the workload.
So give the devices handling the big vocabulary less to process, right?
Right. Try to make everything balanced.
Does that work?
Well, not as well as we'd like.
Really?
It's tough to perfectly match, processing all those words with handling the smaller transformer layers. It's like balancing a scale. You got a bowling ball on one side.
Oh, and like marbles on the other.
Yeah, exactly.
So what other ways have researchers tried to tackle this vocabulary bottleneck?
Well, there's this thing called an interlaced pipeline.
Okay.
It tries to divide the vocabulary work across all the devices.
Sounds promising.
Yeah, but here's the catch. It often needs way more memory.
Oh, no.
Sometimes it makes the problem worse.
So redistribution's kind of clunky, and interlacing can be a memory hog.
Yeah, pretty much.
This is where our paper comes in, right?
They introduced this new technique called vocabulary parallelism, and the results are pretty awesome.
Okay, tell me more.
Instead of trying to work around the vocabulary layers, they just tackle the problem head on.
Okay.
They partition them.
Partition.
Yeah, like breaking that big block on the assembly line.
Oh, into smaller chunks that are easier to handle.
Exactly. Each worker can handle it efficiently.
Sounds much smoother. But wouldn't splitting the task up like that cause more overhead?
You're right. There is some.
With all the devices communicating back and forth, right?
Right. But they were smart about it. They optimized the parts that need the most communication.
Okay.
The forward and backward phases.
The forward and backward phases.
Yeah, of the vocabulary layer calculations.
All right, I'm all ears. Break it down for me.
So during the forward phase, when the model is making predictions, the optimization's like pre-calculating parts of a big equation.
Okay.
They share some of the results instead of each device doing it all from scratch.
So they're streamlining by sharing information.
Exactly. And then the backward phase optimization, that's where things get really interesting.
Okay, how so?
This is where the model actually learns. It looks at its mistakes and adjusts to get better at predicting.
I see.
This involves backpropagation,
Yeah.
like retracing your steps to figure out where you messed up. The optimization, it rearranges the steps in backpropagation.
Okay.
Lets things be calculated at the same time, makes training faster.
Wow, so they speed up both prediction and learning.
Yep, without losing accuracy.
That's amazing. But do these optimizations mean we have to change the whole training process?
Nope, not at all.
Really?
That's the beauty of it. They work with the current pipeline schedules.
Okay.
Like the 1F1B schedule.
Brought up 1B, right?
Yeah. It alternates between making predictions and learning from the errors.
Right, so a balanced approach.
Exactly. Perfect fit for vocabulary parallelism.
That's super practical, but how well does it actually work? What kind of results did they get?
Well, they got up to a 51% improvement in throughput.
51%.
Yep. Means the model trained way faster compared to the other methods.
Wow, that's incredible. Anything else?
Oh yeah, they saw a big reduction in how much memory was used, especially with large vocabularies.
That's huge.
And get this, when they combined vocabulary parallelism with a special memory balance schedule called VHAF.
VHAF.
Yeah, remember how we talked about the vocabulary layers causing memory imbalances?
Yeah.
VHAF smooths those out, manages how data moves between devices.
So they solved two problems at once, made vocabulary layers more efficient, and kept memory usage balanced.
You got it. A total win-win.
Totally. But you mentioned splitting the vocabulary tasks adds overhead. What happens as the model and vocabulary get bigger? Does it stay efficient?
Great question. The researchers found that it scales remarkably well, meaning it stays efficient even as things grow.
Wow, so it's not just a quick fix, it's built for the future.
Exactly. And this, seemingly small technical solution, it actually hints at something much bigger.
Oh, do tell.
By figuring out that vocabulary size is a bottleneck, they've uncovered a fundamental limit in how we're approaching language and AI.
Whoa, that's deep.
It really makes us rethink our methods as we try to create even smarter AI systems.
This is making me think about language models in a whole new way. So we've got the problem, we've got solutions, and we've got some pretty big implications. What are the big takeaways for our listeners? Why should they care about all this technical stuff?
I think this research shows that even the technical challenges in AI can have big consequences. It also highlights how important it is to optimize every little thing for efficiency.
So every detail matters?
Absolutely. And for the future of language and AI, where do we go from here?
That's a great question. It's the perfect segue into the next part of our deep dive.
Perfect.
We've laid the foundation, we understand the problem, we've explored a solution. Now, let's dive deeper into the philosophical implications of vocabulary size.
Yeah.
What it reveals about how we're approaching language and AI today.
This is going to be good. So, like we were saying, this research, this vocabulary parallelism thing, it's not just about making AI training faster.
Yeah, you mentioned that before. It really got me thinking.
It's really about, challenging what we think we know about how language works in AI.
That's a pretty big idea. So if vocabulary size is such a big problem, does that mean we're doing language and AI wrong?
I wouldn't say wrong necessarily. More like maybe our current methods aren't the best for the long run.
Okay, I see.
Think about how complex human language really is. We've got slang, idioms, different ways of talking in different places, new words popping up all the time.
And don't forget sarcasm.
Oh, yeah, definitely.
Yeah.
Sarcasm, tone of voice, all that stuff we humans understand without even thinking about it. That's super hard for AI to grasp.
So are we saying we need to completely rethink how we represent language to AI, like go beyond just words and grammar rules?
Yeah, that's one way to go. Some researchers are looking into adding more context to language models.
More context.
Like giving them real-world knowledge, understanding of culture, even emotions.
So instead of just teaching a model to predict the next word in a sentence, we're teaching it to understand what the words mean, the intent, the whole picture.
Yeah, almost like teaching it to think more like a human. Wow. But there are other approaches too, like making models more adaptable so they can learn new words on the fly without needing to be retrained from scratch.
That would be incredible, keeping up with how language changes all the time.
Right. Much more useful in the real world where language is always evolving.
This is blowing my mind. But I'm guessing this research paper we're looking at, it doesn't really cover all these big philosophical questions, does it?
You're right. It focuses on the technical side, making pipeline parallelism work with huge vocabularies.
Right.
But what it found has implications that go way beyond that.
Like ripples spreading out from a single drop in the water.
Exactly. By showing us this bottleneck, this research makes us look at the limits of what we're doing and think about the future of language and AI in a whole new way.
So where does this leave us? What are the key things our listeners should take away from all this?
I think there are 3 main points.
Okay, Lama Mommy.
First, even technical problems in AI can lead to big questions about language and intelligence.
It's like technology and philosophy are all mixed up together.
Exactly. Second, making AI training better isn't just about speed. It's about efficiency, scalability, being able to handle the complexity of human language as these models get bigger and more powerful.
So we need to be smart about how we use all that computing power.
Exactly. And third, this is a call to action. We need to keep pushing the boundaries of how we approach language in AI. New models, new techniques, new ways of thinking.
Because there's so much potential, but also a lot of challenges.
Yeah, for sure.
I don't know about you, but this is really inspiring me.
Me too. It's exciting to be a part of this.
It's a bit overwhelming too, though. So much to think about. So many possibilities.
That's what makes it so cool, right? AIO is always changing, always pushing us to learn and adapt.
And that's what this deep dive is all about, helping you understand these complex things, finding those nuggets of knowledge, and making you think differently about the world.
Couldn't have said it better myself.
But we're not done yet. We've covered a lot. But there are still some really interesting details in this paper we haven't talked about.
Oh, like what?
Like how vocabulary parallelism works with different pipeline schedules and what it takes to actually implement it in real-world systems.
Right, those are important points.
Let's move on to the final part of our deep dive and get into those nitty-gritty details.
Sounds good.
Okay, deep divers, we're back, ready to finish up our exploration of this whole vocabulary parallelism thing. We've talked big picture, we've talked philosophy, now let's get into the nitty-gritty.
And I think you'll find these details, they really add to the whole picture.
I'm all for that. One thing that's been bugging me is how vocabulary parallelism works with different pipeline schedules. You mentioned 1F, 1B before, but are there others? Do they all play nice with vocabulary parallelism?
Great question. It gets at how practical this is. Can we actually use it? The researchers, they actually tried it with a schedule called VHAF.
VHAF, right. That rings a bell. Remind me again what that is.
Sure. VHAF, it's made to handle those memory imbalances from the vocabulary layers. Remember we talked about how those layers can hog all the memory? Well, VHAF is like a traffic cop. It directs the data flow between devices and keeps things smooth.
Right. It all comes back now. So when you add vocabulary parallelism, does it mess up that balance?
Nope, not at all. Actually, they found that combining the two, vocabulary parallelism and VHAF, it gave them almost perfect balance in memory usage across all the devices.
Wow, so they're solving two problems at once, making the vocabulary layers efficient and keeping the memory balanced. That's pretty slick.
It is really elegant design. It's not just a patch, it's a real improvement that works with what we already have.
Makes sense. But I gotta imagine actually using this in a real training setup, it can't be that easy, right?
You're right, there are some bumps in the road. One is that splitting the vocabulary layers does add some overhead, especially with smaller models.
So for smaller models, it's not as big of a deal.
Exactly. The real benefit comes when you've got those huge models and vocabularies.
Okay, that makes sense. What other challenges are there?
Well, making sure the devices talk to each other efficiently, that's key. When you split the vocabulary work into smaller pieces, you need to make sure they can share information quickly. The researchers did some clever things to speed up this communication, overlapping it with computation and prioritizing some tasks over others.
Sounds like they were prepared for those hurdles.
Definitely, but like with any breakthrough, there's always room to make things better. For example, a lot of what they did was in Python, which isn't the fastest for these kinds of heavy-duty computations.
So there's potential to make it even faster.
Absolutely. They suggest using a lower-level language, like C++ May, could really boost performance. They also talk about maybe fusing different parts of the vocabulary layer calculations together to cut down on overhead.
It's like they're always looking for that extra edge.
Exactly. And the cool thing is, as hardware and software get better, we can expect even more creative solutions. This research is just the beginning.
This has been a fascinating journey, really eye-opening. We've seen the technical side, the challenges, the potential for making things even better. Before we wrap up, I want to go back to something you said earlier about this research being a call to action. What does that mean for our listeners, for anyone who's excited about the future of AI and language?
It means we can't be afraid to dive into the complexity, to question what we think we know, to explore new ideas. We need to experiment, try new things, and push the limits of what we think AI can do with language.
I like that. I think that's a great place to end. Deep divers, thanks for joining us on this deep dive into vocabulary parallelism. It's complicated stuff, but hopefully we've given you a good look at what's going on, what's being done, and what the future might hold.
It's been great being here.
As always. And to our listeners, keep those brains working, keep asking questions, and keep exploring the world with curiosity and a sense of wonder. Until next time, happy diving.